Hello and welcome to our next section on surface area. Today we're going to be talking about pyramids and cones. Now, pyramids and cones are different than prisms and cylinders. Notably, is the most noticeable part is that whenever you have a pyramid, you actually only have one base. So it is still a three-dimensional figure, a 3D solid or object with one polygon as its base. So with a one polygon base and a vertex opposite of that base. Opposite of the base. Okay, so a pyramid. Let's start with something a little more basic. Let's say it's a rectangular pyramid. So just like before, whatever the word is, whatever the polygon name is, that is the base of the shape. Let's move this down a little bit, just a little bit. Okay, so here's our base. This is the base of our pyramid. So this is a rectangular pyramid. Rectangular pyramid. Okay, we're gonna have a lot of components to this, so bear with me. I'm gonna draw a vertex at the top, so this is our vertex. Then we're gonna connect all of the base points to that particular vertex. Okay, so here we have our pyramid. And then I'm going to erase the parts that we shouldn't be able to see. So that's this entire backside. All right. So that entire bottom backside we should not be able to see. And there are a lot more components to this, so bear with me for a little bit. We still have an altitude, but the altitude, just like a mountaintop, goes from the very, very top down to the to the base, and it actually creates a right angle. And I know this doesn't look quite like a right angle, but bear with me. Let's pretend that it is. I'm also going to draw a segment from that is perpendicular to that altitude. So let's do this. Let's label this first. This is your altitude, because it goes from the very, very tip top altitude, that's your U, to the base. Okay. Now this is the same concept if we have a rectangular pyramid or rectangular prism. The lateral edge and the altitude are the same thing because they are both the tallest parts. Okay, so don't mix this up. Actually, let's leave this here for now. Don't bother copying this down yet. I'll explain this in a second. We have lateral edges here, so I'm actually going to, just like before, I'm going to highlight the purple parts as the base. So that's what we did last time. And then I highlighted the lateral edges in blue. Lateral edges occur when we're going from side to side, right? And here we have 4 lateral edges, just like a rectangular prism does. Rectangular prism, we had 4 lateral edges. And then the one you can't see in the back. Okay, so lateral edges still occur, except this time, the lateral edge is not the same thing as the altitude. So that's another important feature. A lateral edge, once again, is not the same as the altitude. In a rectangular prism, it is, because it is a corner, and it is it goes from the highest point to the lowest point. It goes from base to base. Okay, so that is a key difference in this. We also have a new thing called a slant height. So if you have a lateral edge, that's all the highlighted in blue. And then in green, I'm going to go from the vertex down to this edge right here. And this is also going to be a right angle. So if you think of the face of this triangle, this is the face of the pyramid. It goes straight down on the side. We have a slant. We have our slant height. Okay, so here, let's erase this so it gets out of the way. It is perpendicular to the base, and it goes to the vertex. So slant height. It goes from. It is perpendicular to the base edge. And connects. That looks terrible. And connects the base edge to vertex. And this is, I'm defining this because this is very, very important definition, because this is part of our equation. In order to actually solve for the surface area of a pyramid, we need that slant height. We need to know what that is. And if you notice that we created a right triangle. So there's a lot of pieces here. I'm going to do this let's do this in orange, just to highlight this a little bit better, just so you can see it. That is our right triangle. Sometimes you're going to have to use it, sometimes you won't, and that's perfectly okay. And now we have everything, all the terms we need to actually solve for the lateral area of a pyramid. The lateral area of a pyramid, well, is equal to, lateral area, LA, is going to be equal to 1/2 the perimeter of the base. So just like before, just like when we had this rectangular prism, we needed the perimeter of the base, multiplied with, not the altitude this time, but the slant height. And we use the letter L for slant height. So I'm going to put this here, letter L for slant height, and a cursive L at that. Okay, so let's pretend, for instance, we have a pyramid here that has, this is a length of 8, which means we could have a length, this red segment is 4. We could give this altitude, this red altitude, we can make this a 3. And we could actually solve for, we also need the full perimeter. So let's say this full length here is 6. And we could actually solve for this now. If you notice, we have a red triangle, the red and green triangle. So if I wanted to piece this together, I could do that. Red, right angle. Green would be the slant height. The altitude here is 3. The base here is 4. It's not drawn to scale, so we have a 3, 4. The slant height has to be 5. Okay? So, in this particular case, we have the slant height of 5. We know that the perimeter of the base is going to be equal to 6 plus 6 plus 8 plus 8, which is 28. So we could take this, we could start solving. 1/2 times 28 times the slant height of 5, which is in reality 14 times 5, which is 70. So we have 70 units squared for the lateral area. But lateral area is not the whole story. We know the pyramid has only not 2 bases, but 1 base. So that's, like I said, the key difference between a rectangular, or any prism, or cylinder for that matter, and a pyramid, or even a cone. There's only 1 base. So this time around, total area or surface area of a pyramid is going to be equal to lateral area plus the base. Just 1 base this time. Okay, so in this particular case, the purple part, or the area of this base, is going to be equal to 6 times 8, which is 48 units squared. We know the lateral area here is 70 units squared. And we can just add these together. So the surface area of this particular pyramid should be equal to 118 units squared. Okay, so there's your rectangular prism. Obviously, if it's a pentagonal prism or a pentagonal pyramid, rectangular pyramid, if it was a pentagonal pyramid, we would need to find the perimeter and the area separately, and we would have to use a little bit of trig if needed. So, cones. A cone is also a three-dimensional figure, a 3D object or a 3D solid with a circular base and vertex on the opposite side. Okay? And just like the pyramid, we actually need a slant height for this as well. So drawing a cone, we're going to draw a little bit of an oval as its base, because can't draw a full circle, wouldn't look right. Then we would draw pretty much a triangle connecting the two ends. And then we would draw a center of our circle. In red, just like before, I'm going to draw something from the vertex to the center of the circle. There's going to be a right angle here. And then I'm also going to draw a radius. Okay? And in this particular case, the slant height, if you notice, there's also no lateral edge here because all the edges are smooth. There's no corners. In this particular case, our slant height is all around. And then our altitude is once again inside. Altitude. Okay? We would have the radius here, r, and we would solve for r. We would solve for the area of the base accordingly. So, just like before, we're going to solve for lateral area. Lateral area in this particular case is equal to 1/2 of, instead of the perimeter of the base, it's the circumference because we're working with a circle. Circumference times the slant height. Okay? And then the surface area would be adding the circle in, is equal to lateral area plus the base, or, since we know the area of a circle, lateral area plus pi r squared. There's only one base, so it's just 1 pi r squared. Okay, so let's give some values to this and then we'll call it a day. Let's, for instance, say the radius here is 3. Let's say the slant height here, actually, let's not use 3. Let's say this is 5. Let's say this is 12, the altitude. We don't have the slant height. But we do know that this is a right triangle. So we could do some work. Right angle, slant height. We definitely know that this altitude is 12, this is 5, which means the slant height has to be 13. So now we could actually solve for this. The circumference of this, hopefully we remember, is pi times diameter, or 2 pi r. So 1/2 times the full diameter is 10 times pi times the slant height of 13 would be equal to 10 times 5, 10 times 1/2 is 5, 5 times 13 is 65. So we get 65, this is just units because I didn't put a measure there. 65 pi units squared. Don't forget the pi. Now lateral area, a regular area, the area of the base would be equal to pi r squared. We know the radius is 5, so we could say this is equal to, or this part of it is anyways, pi times 5 squared. 5 squared is 25, so we could say this is 25 pi. And then we could plug in the 65 that we calculated earlier, 65 pi. 65 pi plus 25 pi are both in terms of pi, so you could add these together. So the total surface area here is going to be equal to 90 pi units squared. Leave things in terms of pi if and when you can, because it'll be much easier to actually just explain. All right, so those are pyramids and cones. If you do have any questions, please bring them to class, and I'll see you in the next one. Bye.